Hi, in this video we are going to talk about the most important operations as far as the array data structure is concerned. So first, let me tell a few words about the add operation. We can keep adding values to the array as far as the array is not full. So basically, we have an array that can store up to 8 items. At the beginning it is empty, so we are able to add 34. It's going to be the first item, so we are able to get it with the help of index 0. We are going to add 12. We are able to get this value with the help of the index 1. Then we are able to insert, for example, 120. It's going to be the index 2, then -5. So we can come to the conclusion that when adding new values to the list, we just have to insert it with the next item possible. Okay, in this situation, we know for certain that the index 3 is occupied, so we are able to insert the next item to the index 4. And it is a very fast operation. We can do it in order 1 constant time complexity. But it's very important that we are inserting items at the end of the list. If we would be inserting item at the beginning of the list, then we have to reconstruct it. And that's why it's not going to so fast. But if we insert items at the end of the array, then it's going to be very fast. We can insert item for a given index. So for example, I would like to insert 23 to the index 1. So we have to search for index 1. It is quite fast, but we come to the conclusion that this slot is occupied in the sense that we have to shift every item in order to be able to make space for this 23 value. So after moving these values, we are able to insert the 23 to the index 1. So it is a bit more problematic. Sometimes we have to shift lots of values in order to be able to insert the new one. So that's why it has linear time complexity, because we have to move items in order to make space for the item we would like to insert. Let's consider the fact, for example, that we have 10,000 items in an array and we would like to insert some other value at the beginning of the list. Then we have to shift 10,000 items. And that's why it's going to have linear time complexity, and that's why in this aspect, arrays are not always good solutions, because linked lists are going to solve this problem in constant time complexity. So that's why it's very important to know the difference between linked lists and array lists, because it depends on what kind of application we would like to implement to know that what data structure to use, because sometimes arrays are better, but sometimes linked lists are better. So we have to know what kind of application we are going to use it. Okay. So we come to the conclusion that as far as the insert operation is concerned, adding a new item at the end of the list takes constant time complexity, very fast operation. If we insert items at a given index, it's going to have linear time complexity, because for most of the times we have to shift the items in order to be able to make space for the value we would like to insert. Then what about the remove operation? We would like to remove the last item. And it is very simple, we just have to remove it in constant time complexity, of course. I would like to get rid of the last item, so we have managed to get rid of -5. I would like to remove it, so I remove the 120. Okay, but if we would like to remove a value with a given index, it is not that simple, because we may have to shift items. So that's why again, it's going to take linear time complexity to remove an item with a given index. For example, I would like to remove the item with the index 1. Okay, this is the index 1. I remove it, but then we have to shift these items because there is one value missing and it is forbidden to leave the array like this. So we have to shift it like this. Okay, and basically the overall complexity will be linear at the end. Okay, so removing the last item takes order 1 constant time complexity, but removing, for example, the middle item takes linear time complexity order 1, because again, we have to shift lots of items in order to reconstruct the array. So basically that's all about the array related operations. And you may pose the question that, okay, what's the conclusion? Arrays are good data structures or not? And the answer is that it depends on what kind of application we would like to use. If we would like to insert items at the end of the list, or we would like to remove items from the end of the list, then of course it's going to be very fast, because it's going to take ordo 1 constant time complexity to do these kinds of operations. If we would like to insert or remove items from the middle of the array, then of course it's not going to be very good solution to use arrays, because it's going to take ordo n linear time complexity, because we have to reconstruct the array from time to time because of the shifts. Thanks for watching.